Hi everybody, welcome back to let's think of this as our take two in a way of the rest of the lecture for tonight. I'm hoping you'll all take a few minutes just to kind of watch through this video. I'm going to cover what we unfortunately didn't have the opportunity to finish up in class. I know it was a little bit hectic with the smartboard issue, and then we did want to cover everything so we could go over expectations this morning. Um, so for now, I'm going to skip ahead. I know the first couple of slides are going to look familiar, but we will get to less than greater than, which we'll talk about in class. That's probably something that's from a previous course. That includes the natural numbers, which is a fancy way of representing the set 1, 2, 3, and so forth. Cardinal numbers was one of the last things we had covered. Finite versus infinite, equal versus equivalent. So to pick up where we had left off, I had started to talk about, just to give a general introduction, that a subset it's a smaller portion, a smaller set, if you will, of some generic or general starting set. So it's always going to be contained based on it's a smaller piece of what our initial set was. So bear with me, the pen might jump around a little bit. I'm using a rather primitive tablet to write this up for you guys. So in this case, a smaller piece of some initial set. Initial or even bigger, if you will. So some initial bigger set. Now we denote subsets very similar to how we had the symbols for is an element of and is not an element of. We have a symbol it's kind of like a sideways C, just a bit elongated. And for is not a subset of, it's the same thing with a slash through it. Now, what we have up here, there's actually a couple different ways of seeing this. And I had neglected to mention this. There's a little line under it. So to kind of zoom in, I know that's a bit squished here, but it's a C shape with a line under. This is also called set containment. Now, with set containment, again, if we think subset, it's one set is encompassed by another. An example of this, let's see, so if you go to the library, all of the books in the library can be a set. However, let's say your specific textbook is a subset of every book that's in the library, since there could be hundreds, if not thousands or so, of those different books. Now, a couple of different ways of looking at things. So a lot of times, I guess more for a visual idea of subsets, let's say this big circle here represents all students at Delaware Tech, or all the classes that Delaware Tech offers. So let's say this is DTCC classes. Now, within this, we have our Math 120. And any Math 120 class could be considered a subset of the DTCC classes, since this is a course that we offer here. You can even have a subset such as your psychology course, your chemistry course, really anything that's related to your field. So MAT120 is considered the subset. Now with this, if we look at we have a couple of numerical examples here. In this case, we are comparing A to B. Now, when we first look at something like this, in this case, they're asking us to fill in the blank to make the statement true. Now, which one of these is a subset of the other? In order for it to be a subset, it has to be either exactly the same as the initial set, or it can be elements from the other set. So I know that's a little bit tricky to think about. Now, if we notice here that 1, 3, 5, and 7 are all contained, they're all elements of what's here in B, since B is 1, 3, 5, 7, 9, and 11 as well. So there's some stuff there that's not included, but what that's saying is, in a way, that A is completely contained within B, and therefore A is a subset of. So our true statement here would be A is a subset of B. Just like with the is an element of, that little symbol represents a couple of words there. It would mean is a subset of or is not a subset of, depending. Now, for a more visual picture of this, let's say that this big circle represents set B, since B contained a whole lot of stuff in it. And then within that, we have another little circle here. Let's call that A. Now, B contained 1, 3, 5, 7, 9, and 11. Now, because 9 and 11 were the only things that are not in A, everything that would be in A, we would put within the A circle, since that's A inside of B. So visually, we have something that hopefully this is just maybe a little bit more clear as to what what we're kind of talking about. And I will briefly go over this in class again next week. I'm very sorry that we had some issues with Smartboard and such, but hopefully we'll be able to sort that out for next class. Now, for the next one, we're given, in this case, set builder notation. So we see our x such that x and y such that y. Now, in A here, x is a letter in the word proof. Well, what letters are actually in there? Let's see if we can convert this to roster notation to maybe help ease what we're looking at. Well, P is there, R is there, O, and F. So in roster notation, we would have PROF. Now, for letter B here, it's a word that's in, or the letters that form the word roof. Well, that's going to be R, O, and F. Notice how I had only written the O's once. That's because since they appear multiple times within the word itself, since we're asking for only the different letters of those words, technically the O is not going to repeat itself. It doesn't out of nowhere become a secondary letter, as if you have it once, it only has to be written once. So with that, is A a subset of B, or is A not a subset of B? We're going to determine that based on what we have here. Now, if we look up top, we see that B is actually missing something that A has. Now that's a big problem, since in this case B is actually, if we look at it, contained within A. However, they want us to make this statement true, and therefore this we would use a not subset of. A is not contained in B. However, the other way around would be true. So true statement of this would be B is a subset of A. And that is all based on what we're given within the set itself. So for our final example with subsets, so X such that X is a planet of Earth's solar system, and then we're given B, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So let's see here. Would this be a subset, or would it not be a subset? Well, does B contain every one of our solar systems? So with this, in this case, it is true. Again, it's kind of, I guess, relative to what you believe. Recently, they say that, some planets may not actually be planets. In this case, we're going to keep it simple. That is a true statement. And that's because one is just a set builder way of denoting the other. So they're actually equal sets because they mean the same thing. And equal sets are also subsets of one another. I know that kind of seems funny, but if we think of a visual here, well, if we have all of these different planets, I'm just going to abbreviate a few in here. Now, if each of those appears and everything is exactly the same, that means that if this is A, it's also the same thing as B. So since there's no discrepancy, they are the exact same thing. Now let me take a peek at what we have ahead of us. In this video, I'm going to continue talking about with the proper subsets, and I will end up splitting these videos so they do not become too long, so if you only have a few minutes, you can watch them. So we can also have something that's called a proper subset. Proper subset it has one very subtle difference than a standard regular old subset. The only difference for a proper subset, it's a subset which has cardinality at least one less than the set itself. So another way to think of that, has at least one less element. So it has at least one less element than the initial set. So then the bigger set. So if we think about this, if we have, um, so if A is a proper subset of B, there is no way possible that they can be equal sets. Even if something is a subset of one another, there's no rule. It's just kind of here we're trying to tie things together. So to be a little more specific, let's look at some examples. Notice on the left, this is our generic subset. And the visual difference here is that this means proper subset. And the same rule applies if you're trying to say something is not a proper subset. You'll put just a little slash through it, and that'll be perfect notation for it. For the most part on the test, though, it'll be either a true-false question, maybe a fill in the blank, but true-false questions are pretty good for this. So we have here A equals, or in other words, the set A equals X such that X is a person and said person lives in San Francisco. And for set B, we have X such that X is a person and that person also lives in California. Now, if we think about kind of our different towns, this one might not be as obvious to everyone. This is a true statement, and technically that would be a proper subset since, you know, there's San Francisco in California. You have a whole bunch of different places you could go within California, not just San Francisco. That's one specific location as opposed to every town that is there. So that person itself, I'm trying to think of a good way to describe this. That person themselves, they will live in, or however many people, just because they live in San Francisco, they must also live in California. However, they're not necessarily going to live in other towns. Now, that one is quite a bit trickier. Now, in this following statement here for letter B, we have two sets, which if we look at closely, we'll notice that these are actually equal. Now, if you determine that two sets are equal, right off the bat, that tells you that they cannot be proper subsets. So therefore, that's what these little three dots mean in a triangular form. Just means therefore, these can never be proper subsets. So visually, that would just be a generic old subset. You could also say this is not a proper subset by putting the subset sign with a slash through it. For this example specifically, we're just looking for one or the other, and if you have to write that, it'll be a little bit more clear. All right, so to carry on with the lesson, if you are looking for more information, please look at the next video, which will be on, we'll start off with empty sets as subsets and go on from there.